Alright, welcome back. This is the third example for section 13.2. We're looking at trying to give a recursive definition for the given sequence. So we're given 1, 9, 36, 100. So a recursive routine has kind of two parts to it. We have t sub 1, so our first term, which in this case is just going to be the 1. And then we have t sub n, which again is typically has some relationship to do with the previous term. So typically we represent that by being t sub n minus 1. But the question is, are we multiplying, are we adding, like what's happening, right? That's what we need to figure out. So what we're going to do then is go and explore our sequence of 1, 9, 36, 100. So taking a look at this sequence, probably the first thing to look at is there something we're, adding, subtracting, multiplying, etc. to get through our terms? Well, we could start by talking about multiplication. They were multiplying by 9, multiplying by 4, and then multiplying by some interesting numbers, so probably 3 point something. If we look at that, I'm not really noticing a pattern there. So let's take a look again, and this time we'll look at the difference between our two, so not a geometric. So looking at the difference here, we're getting a difference of 8, a difference of 27, a difference of 64. The idea that that's how much we're adding. Unfortunately, there is still not a common difference in this case, so it seems like this is also not going to be an arithmetic sequence. So we've kind of struck out on both of those. So after that, it's kind of up to you to think about old information, things that you know from previous classes, what do you know about sequences, etc. Now, if we look at 8, 27, and 64, those numbers seem kind of interesting because I think even if we start looking at the second difference, may be helpful, may not be helpful, but I really don't think the difference between 8 and 27, which is about 19, and 27, 64, yeah, that's not the same value. But I'm noticing something interesting. I'm noticing that 8 is really 2 times 2 times 2, or 2 to the third power. That 27 is really 3 times 3 times 3, or 3 to the third power. And 64, I believe, is 4 times 4 times 4, so 4 to the third power. So it looks like our difference actually has an interesting pattern, that it's actually, it looks like possibly n to the third power, that we're taking our previous term and adding, for instance, 2 to the third, etc. So if we would kind of combine that together, it seems like we're looking at t sub n minus 1 plus n to the third power. But let's just check that out and make sure we're feeling comfortable with that equation. So if we're talking about 9 as being the second term, it'd be, t sub 2, which would equal t sub 1 minus, be t sub 2 minus 1 plus 2 to the third power. So we get that t sub 2 would be t sub 1 plus 8. And again, t sub 1 is just really 1. So it looks like that is going to indeed give us 9. So in this case, again, had to be a little creative, kind of notice some things that are happening. But that right there would be then your recursive sequence. All right, this is the last example. So good luck with the homework. Please again ask me questions in class if you have any confusion or you want some clarification. Thanks.